Hey there, I'm Sean Albright from the sales engineering team here at Grok. In this video, our goal is to demonstrate and demystify how Grok delivers value by showing you exactly what happens from the moment raw data hits the platform to the moment clear, actionable detections appear in the UI. We'll walk through 3 related real-world scenarios that, while finance-oriented, are relevant to any enterprise with a large, complex IT infrastructure. First, a payment API latency cascade, where a Postgres pool is becoming exhausted, resulting in Kafka consumer lag, ultimately threatening SLAs for transfers. Second, we'll take a look at payout failures at the web application firewall, where in this case, a false positive SQL injection rule blocks legitimate traffic and stalls customer payouts. And finally, an Oracle settlement slowdown, where redo log contention puts the partner settlement cycle at risk. Each one of these scenarios would normally flood operators with noisy, disconnected alerts from multiple tools. But with Grok, they're each correlated, classified, and summarized into clear, distinct, actionable detections. To make sense of it all, we'll walk through Grok's machine learning pipeline, from ingestion to anomaly detection, correlation, classification, summarization, and how that transforms the operator workflow. You'll see how Grok's brain applies not just one, but a comprehensive suite of machine learning algorithms to transform raw inputs into clarity, and why that matters for your business. Before we dive into the pipeline, let's first take a look at what we're starting with. Here's the raw data. Dozens of unstructured alerts and log entries scattered across different layers of the stack. From the payment API, we see latency violations, database connection pool alarms, and Kafka lag metrics. From the web application firewall, we see block traffic, API 500 errors, and retries backing up in the dead letter queue. And from the Oracle settlement system, we see noisy database alarms, batch job failures, and application errors. Each tells a piece of the story, but on their own, they're just noisy and overwhelming. Let's now look at how the Grok pipeline processes that raw telemetry and applies machine learning to strip away the noise and give operators clarity they can act on. Step 1 is ingestion. Grok Connect provides a powerful and flexible service to take in raw logs, alerts, and metrics in almost any format. Whether it's traps, syslog, CSV files, JSON events, or API feeds, Grok shapes them into a common structure for downstream processing. For this demo, we used built-in utilities to feed in simulated events, but in pilots and production, Grok provides secure endpoints so our customers can feed real data directly from your monitoring and observability tools. Once ingested, Grok applies machine learning across the pipeline. First, anomaly detection algorithms flag behavior that deviates from what Grok has learned to be normal in the environment. When something wavers from that baseline, it kicks off anomalies. Next, clustering and correlation algorithms recognize events that occur together based on historical patterns and automatically collapses those symptoms into a single representation of a larger issue we call a detection. From there, Grok asks, do I know what this means to the business? If so, it classifies the detection, drawing on prior behavior and its inferred understanding of the meaning and priority of that issue. And finally, summarization. And this is where Grok Guru really shines. Instead of leaving operators to interpret a wall of technical details, Grok Guru generates a human-readable summary of the detection. It clearly explains what happened, identifies the likely root cause, and even suggests recommended actions the operator can take right away. So by the time a detection reaches the level 1 queue, it's not just condensed, it's clarified and actionable. All right, now that we understand at a high level how data is ingested and processed through the pipeline, let's dive deeper into each specific scenario. Okay, in our first scenario, we have payment API latency caused by Postgres pool exhaustion driving Kafka consumer lag. In the detection detail, we can see the pipeline in action. Grok has ingested dozens of raw alerts from Dynatrace, CloudWatch, the Kafka exporter, and Kubernetes, and applied correlation to connect them across the application, database, and messaging layers. Let's take a moment to dive a little deeper and demystify how this actually works. To help operators understand why Grok decided to group these alarms into the same detection, we provide an explainability tab. As you can see here, Grok grouped these events because their specific dimension values share similar historical patterns, suggesting they point to the same underlying issue. By specific, we mean the combination of node, like a device or host name, and event type. Below that, you can see how Grok's brain has learned that these alarms are related. Grok looks at historical patterns of when alarms fire in time and continuously learns how strongly each alarm is related to every other alarm it has ever seen. For example, the chart here shows that the alarms in this detection also occurred together in the same time window on June 26th. Two of the alarms also co-occurred on August 1st, and the other two co-occurred again 2 weeks later on August 15th. When alarms fire together in the same window of time, we call that a co-occurrence. Grok tracks both co-occurrences and single occurrences, then uses those patterns to calculate a pairwise similarity measure for every unique alarm or symptom it has ever seen. All right, those correlated events are then classified in this case as a payments service issue, and Grok Guru summarizes everything into clear, human-readable business language. The result is one actionable detection instead of dozens of disconnected alarms. Without Grok, operators probably swim in APM problems, database alarms, pod restarts, and lag metrics, and manual triage across multiple tools means MTTR stretches into hours. With Grok, one detection in the UI, enriched with evidence like latency spikes, database connections, and consumer lag, plus recommended actions drawn from how similar patterns have been resolved before. MTTR drops from hours to minutes. The business impact is huge, protecting transfer SLAs, reducing abandonment, and preventing churn. All right, now let's move to scenario 2, payout failures at the web application firewall. In our next scenario, we have payout failures due to a false positive SQL injection rule in the web application firewall. Legitimate traffic for the payout API is being blocked. And those failed transactions don't just vanish. They pile up as retries in the dead letter queue, which in this case is backed by the queuing service. So we've got another cascade of issues happening here. Without Grok, a situation like this would likely result in at least 3 separate tickets in the incident management system. One for the application firewall, one for the API gateway, and one for the queuing service. And most likely 3 separate war rooms to go with them. Operators might get contentious over ownership while customers wait and corridor revenue and trust bleed out. With Grok, the pipeline takes over. Alerts from the WAF, the API gateway, and the SQS queue are ingested and automatically correlated into a single detection tied directly to the payout service. That cluster is then classified as an API payout service failure, and Grok Guru summarizes it so operators see the root cause immediately. A false positive SQL injection rule breaking payouts in a specific corridor or region. So instead of multiple tickets and war rooms, operators see one detection with corridor level business context, complete with a suggested remediation. Apply a scoped WAF exception. MTTR drops to minutes. The business impact, payouts keep flowing, escalations drop, and corridor revenue is protected. All right, finally, let's take a look at scenario 3, the Oracle settlement slowdown. Okay, in our final scenario, we have settlement delays caused by Oracle redo log contention that's slowing down ORMB batch jobs. Without Grok, these legacy Oracle workloads generate a ton of noise. DBAs are buried in Oracle Enterprise Manager, SREs are buried in Kubernetes pods, and finance teams chasing down missing settlements. Mean time to resolution stretches from hours into days, and compliance fines start to become a real possibility. With Grok, the pipeline connects the dots. It ingests telemetry from OEM batch logs, application pods, and correlates those events with the downstream batch job failures. That cluster is then classified as a batch processing and database issue, and Grok Guru summarizes it for the operator. The partner settlement cycle is at risk due to distinct issues affecting batch processing, database performance, and service stability across different hosts. So instead of a mess of alarms across silos, operators see one detection in the UI, batch processing and database issue. It's enriched with evidence and a recommended fix for the DBAs, giving them a direct next step. MTTR drops from days down to under an hour, and the business impact here is critical, protecting partner trust and avoiding penalties. In each of these scenarios, payment API latency, payout failures at the WAF, and Oracle settlement slowdowns, Grok's pipeline follows the same flow. Ingestion, correlation, classification, summarization, and presentation of a single, clear, actionable detection. That's how Grok cuts through the noise and turns complex enterprise failures into clarity and speed for your teams. Thanks so much for watching. Please don't hesitate to contact us if you have any questions.